Hi there, and welcome to the AbsInt Videocast for the October release 23.10. My name is Christian Hümmert, and I'm going to show you the latest updates on our binary level analyzers, aiT, StackAnalyzer, TimeWeaver, ValueAnalyzer, and the TimingProfiler. The first major update is a security update, actually. With this release, we introduced TLS Encryption for all not network connections between the AbsInt License Manager server and the new ACube client programs. While in these previous releases of ACube, we had these two communication channels which were unencrypted between the client and the AbsInt License Manager. This one for the license token communication, and this one for communicating with the web interface of the License Manager on these default ports, by the way. We now introduce TLS encrypted channels for the license communication and the HTTPS communication with the web interface. For that, we introduce new ports. This one is the 42426 is the default port for the license token communication, and 42427 for the HTTPS communication. Please note that the other two channels, the unencrypted ones, are still opened even if you install the new AbsInt License Manager version for compatibility reasons with older ACube client programs. If you do not want to allow the unencrypted communication at all, please add these two ports to your firewall and plug them. Please note that all new versions for ACube, starting with 23.10 release, require a encrypted TLS communication for the AbsInt License Manager. So that means you have to install the latest AbsInt License Manager program if you want to run a 23.10 version and newer of ACube client. Let me give you a few more details on this encryption update. So I switched here to my Windows environment and I've opened a freshly installed release version for the ACube for RH850. It's not yet connected with the AbsInt License Manager program, and I'd like to connect it with the ALM running on my Linux server called Dagobert. For that, I can either go via this button here or open the Help License dialog via the menu. Here I need to go to connect to license server, as you know, and select my server machine. So the LM is running here on two different platforms, here locally and on my Linux server Dagobert. So I'd like to take this one. What you see here is, first of all, that we are now using the new TLS port for the connection, of course. And we have a new option called Verify TLS Server Certificate. Well, you will see that I do not have a valid TLS server certificate right now for Dagobert available on my machine. So if I check this option here and would like to establish the connection, it won't allow me to do that because the certificate is not available. But fortunately, I can ignore that if I trust my connection, my TLS connection here to the Linux server. Then it will still allow to establish the connection. So now I'm connected with Dagobert, with the ALM running on Dagobert, and I can use the analyzer. You see, everything is set up correctly. But here, this button also indicates that there is no TLS server certification found. Well, what else? If I would like to open the web interface of the LM via Manage License Server, you also might see a different effect now, because again, an HTTPS connection will now be established, which usually requires as well a TLS certificate, right? Again, this can be ignored if you click on Advanced and say Continue to Dagobert with an unsafe, potentially unsafe connection. Then you still can reach the AbsInt License Manager. Or alternatively, if this option is blocked in your system to continue an HTTPS connection without certificate, you can switch to your system, to your Linux system. I'll do that here. and go to that one remotely and open it on the local host. For instance, here with the older HTTP port 42425. This will still be working. Let me now give you a short update on our graphical user interface. The first update affects the AbsInt launcher program, our dispatcher for all ACube clients that are installed or available via the portable zip archive. So in previous versions of the AbsInt launcher, you could start them and it lists only those ACube clients that have been globally installed in your environment. But sometimes our users do not have the privileges to install the tools on their systems and use the portable zip archive and place them in some folder, like here, for instance, in the AbsInt folder. And you may have more than one portable zip extracted there. Now, the new version of the AbsInt launcher program, if I choose one of them here, if I enter the ARM version, for instance, go to bin and execute the launcher, will also discover the other client programs for the TriCore and the VH850, which are located nearby. So it can also start the ACube for TriCore, even if it was not globally installed from here. Next new feature affects the workspace mode in the GUI. So I've opened here our famous scenarios example with various analysis items, and let me first remind you on what the workspace mode means. So we can start an analysis here, StackAnalyzer to 1 millisecond task, open the graphical output, the call and control flow graph output. We could also do a WCET analysis, maybe of the 10 millisecond task, and open the statistics. Now, in previous versions of ACube, you could now go to project and save this current state of the graphical user interface with all the results and the current settings. You can save it as a workspace. But this changed the mode of the graphical user interface from the APX project mode to the workspace mode, actually. Now we have changed this behavior. Now you can only export workspace. So if you go here and say, I'd like to export a workspace for the current state, you can do that while keeping the graphical user interface in the APX project mode. So that means if you now change some other configurations in the hardware or somewhere else, you stay in your project where you should do all configuration changes anyway. No? In this release, we have also improved the experience for working with groups in your project. So we see already here 4 different groups defined for the WCET analysis, the stack analysis, the value analysis, and 2 result combinations. But we have added a few more features for working with groups. So you could, for instance, go to one of these groups and add directly into this group a new analysis. You could do right mouse click on the group name and say create analysis and maybe a new AIT analysis here. And you see it is immediately put into that group. And there you can, for instance, add this new analysis, right? Then the next new feature corresponding to groups is that you can move analysis items to new groups, for instance. You could say here, select some of them and move them to a completely new group. This is also new. So you can say, click here, add new group, and you see those are moved to an entirely new group, which you can, as you know, when the name is changed by this slow double click, right? My new group. With this year's April release, we are already introduced the feature to query contents of constant variables from the symbols view. Now, with this release, we have improved the experience with respect to two-dimensional or higher dimensional array variables. And I'd like to give you a short demo on that. As you remember, we first need an interactive value analysis running, no matter which one. I pick here the init VA analysis, but you have to start it interactively. Then we switch to the symbols view, and there is, for instance, this array to clock variable here, which is a two-dimensional integer array, as you can see. And for that one, since it is not const initially, I introduced an area contains annotation, especially this one here, where I annotate each of the 2601 integer elements, no? So 51 times 51 elements we have in total, of 4 bytes each, and I annotated every of these integer elements with this number here. Okay, let's go back to our symbols view. And as you know, you can say right mouse click, query contents of that array. And first of all, you have to select the interactive analysis to use. Well, we have just that one running. And then you can restrict your output now to the indices of the first dimension if you want, or you could say directly, give me the entire output range. Okay, let's do that. And by clicking on OK, you see that all elements, these 2600 and how many was it? One. And each of them have this annotated value. You see, this one would be the first element in the first dimension. This would be the second, and every element is again an array consisting of 51 elements. So it's quite convenient way to visualize the contents of constant variables, which are initially declared as constant in the binary or annotated by an area contains. Let me now give you a TimeWeaver specific update. So first of all, TimeWeaver now supports the RH850 architecture with this release. And then we also added a few more features that I'd like to show you directly in the tool. For that, I've opened the TimeWeaver for ARM and loaded the scenarios example. So let me first start the analysis of the 10 millisecond task and open the graph visualization of it. As you know, you can go to any arbitrary program location here. We have the first basic block. It's followed by the timing node, and the timing node indicates what was the worst case timing, namely 101 cycles to execute these machine instructions here. But you can also use the context menu of this timing node and say show trace segment statistics to load or pre-select the information about that specific trace segment in the trace segment statistics here. And now with this release, per default, we show these timing variance information here with the time units instead of the cycles. You can switch to the previous behavior by clicking on show cycles, and then you also see the cycles as in the previous versions. Then we also added a new option to filter exceptionally high instruction timings because of trace errors or so out of the analysis. So you can go to Setup, Timing Analysis, and here below you find the new options called Threshold for timestamps, and you define the threshold. So that means all timestamps greater than this threshold will be filtered out, and only the non-exceptional timestamps will then be taken for the WCET computation. Let me finally give you an update on our AIS2 specification language. With this release, we introduce a new target annotation. Imagine the following problem. At this program location, you used to have an indirect call instruction, and the compiler decides, for whatever reason, because you have different optimization level or different switches, now to optimize that into a tail call at the end of the routine to save a stack context, for instance. So this also changes, however, the type of the control flow instruction here from an indirect call to a jump indirect, right? And if you now have an existing computed call annotation, this might no longer work after this change. You will get a warning that you are annotating an computed call, but there is an indirect jump or a tail call found. But you would have to change your annotation every time the compiler changes the types. Now we introduce the generic targets annotation, which will no longer change the instructions type and behave like the original computed call or tail call annotation. And the tool or the analyzer derives its type automatically. Let me give you a demo on that. Let's have a look to our 1 millisecond task stack analysis in the AcCube for TriCro here. You know, in our 1 millisecond task, we have a computed call location in the entry function. And in this example, the compiler initially created a tail call at this location, and we annotated that with tail calls, and the targets can be extracted from the message handler table. Now, imagine the compiler has rerun, has created a new executable, and changed, for some reason, this type from a tail call into a call. If you now run the analysis, you will get this warning that at the annotated program location, we no longer have a tail call, a jump indirect instruction, but a call I instruction. And this is considered to, the annotation is considered to be a tail call, but would rather be a regular indirect call, right? So, and we can see that in the graph. Yes, it's no longer a tail call, jump I instruction, it's a call I. Okay. We would have to change that annotation, of course, into calls. And then the warning will no longer exist, and the program is correctly analyzed. But what if the compiler again changes it's back to a tail call later? Well, to have a more robust annotation file here, you could now use the targets annotation, and it behaves exactly like our calls annotation in this case. Because it's auto-detected that we have an indirect call instruction here. And if the compiler changes it again to a tail call, this will also work and produce no warning anymore. This concludes my presentation on the new features of our October release. As usual, please be referred to our website for a complete list of all changes and updates in the new release. Thank you very much for your interest. Take care and goodbye.